Hello everyone, welcome back to our channel. So after completing superposition theorem, Thevenin's theorem and Norton's theorem, we are going to discuss some easy topics like now we are going to discuss about the basic things about DC circuits. So let's see what is a current circuit. So electrical circuit is basically a closed path composed with many active or passive elements. How it looks like here, a circuit having wire and a voltage source or a current source. We having a voltage source and current source and having many of active and passive components, and it must be closed path, meaning all the junction points have to be connected. So this is basically called a electrical circuit. So now a question comes to your mind, what is active component or what is active passive components? So the active components are the elements it supplies any energy to the circuit, and passive elements are the elements which are receives energy from the active elements. It means that active elements are independent and passive elements are dependent over active elements. So now we take a look the parts of passive elements. So in passive elements there are three main parts. There's a resistance, capacitor and inductor. And in active element the main active element is battery. Battery is the or power supply is the main example of active element. So in every circuit resistance is effective, and in case of capacitor, a capacitor is a special type of passive element which absorbs or stores the electrical energy, and inductors are the special type of passive elements which consumes or stores the magnetic energy. And capacitor is effective in the electric field and inductors are effective in magnetic field. So we discussed this about in details in the earlier classes. So let's see, now we are going to learn about Ohm's law. So in class 12 we already gone through the basics of Ohm's law. So Ohm's law is the main Ohm's law states that V equals to Ri. It gives us the main formula, and in V equals to Ri, using V equals to Ri, we can calculate the voltage, current and the resistance using these formulas. V equals to V by I and I equals to V by R. These are we know very easy. and and we know that the unit of resistance is ohm, and the reciprocal of uh, resistance is conductance, which states that G. Then we show the graphical representation of Ohm's law. So in graphical representations, yeah, in x-axis we consider voltage, and in y-axis we consider the current, and when the slope given us the 1 by r component. So easily said that the slope equals to 1 by r. It means the slope of vi graph is gives us the conductance, and its reciprocal is gives us the resistance. So we also said that the tan theta of the slope, if we consider this angle is theta, is equals to 1 by r. Now we see what is short circuit and open circuit. So short circuit is the special type of circuit design where the resistance is zero, and we know that when resistance is zero, the infinite amount of current will flow. And open circuit is the special design of circuit when the resistance is infinity, and we know when the resistance is infinity, that means no current will flow gone through the circuit. Now we going to discuss about the resistors in connected in series and parallel. So if we see two resistor, first we see the series case. So when in a circuit there is two resistors are connected in series and having a voltage source. So we give a name R1 and R2. So basically what happens in this circuit, there are two resistors are connected in series and a voltage source here. The voltage source is giving voltage is V and the amount of current flown through this is I. So basically we see that the same amount of current is flow through the two resistor R1 and R2 and it gives back to the voltage. Main difference is the voltage are differ in this case. Here R1 having V1 voltage, R2 having V2 voltage, but the current is same. So in series, the equivalent resistor R equivalent is basically R1 plus R2, and if the n number of resistors are connected, then it is Rn equals to n plus R. Is the main thing, and here current is always same. So these cases we have to remember in the case of series. Now we are going to discuss about the second case, that is parallel. So in this case, same so having a voltage source V and two resistors R1 and R2, the current flows is I. Now the current is divided into two parts. One is I1 and I2, but the voltage of these two are same. In this case, the voltage of these two are same. So when the two resistors are in parallel, the R equivalent is basically 1 by R1 plus 1 by R2, and if n number of resistors are connected, then R equivalent is going to be R by N. And in this case we have to remember that the voltage is same in this case. So these are things we have to remember in series and parallel connection of resistors. Now we are going to see the voltage divider and current divider. So in the earlier discussion, we see that when the two resistors are connected, the current is same and the voltage is divided into two parts. One is V1 and V2. So now we are going to see how to calculate the V1 and V2. So basically two main formulas are there. It is coming in all the competitive exams and all the theory basis questions, that V1 and V2. So how to calculate the V1? So V1 is the voltage across the resistance of R1. So V1 equals to total voltage V into the calculated resistors. What is R1 and the rest resistors R1 plus R2. Okay, and V2 is samely total voltage into the required R2, the given resistance and the measured resistance, and rest is the rest of resistance. So these are the two formulas of voltage divider law and V1 and V2. Now we are going to discuss about current divider law. So current divider law is considered in the when the two resistors are connected in parallel. So when two resistors are connected in parallel, the current is divided into two parts. One is I1 and I2, and the voltage is remains same. So how to calculate the current? So these are the two formulas. It is little bit different from the voltage divider law. So when I calculate the I1 is the total resistance into I1 is the current of the R1 component, but we have to consider here the R2 resistance, and then we write the R1 plus R2, and when we calculate the I2, then samely it is total current into here I2 is the current flown through the R2 resistance, but we write here R1 by R1 plus R2. So these are the two important laws. One is voltage divider and current divider. So that's it for today. See you in the next video. Thank you.